Okay, hello there. Thanks for studying for your exam. We're going to do just a couple problems out of every one. The first four is just talking about patterns. You just got to figure out how are the numbers changing and what the next couple of numbers would be. For example, number 2 there, number 1's pretty easy. Number 2, you see that the numbers are getting actually bigger because you start with a negative 29 here and then you go to a negative 12. So you could be adding 17, and then you add again to get 5 here. We're adding another 17. I like to write them in there, plus 17, plus 17. Add another 17, so that's going to give you 22. And another 17 is going to give you 39. Okay. That's how you do the patterns. Don't think we need to spend a whole lot of time on that. Number 5, talking about the conjecture. Basically, what's your conclusion? If you look at the product, which means answer to a multiplication problem, of any two even numbers, they give you a whole bunch of examples here. All right. What do you notice about every one of these answers? You should notice that they are even numbers. Okay, so that's your conjecture. Says what's your conclusion based on the information that they give you. Okay, number 8, 9, 10, 11, there's a lot of questions about this. Collinear points, all right. Collinear points means they're all three on the same line. So for example, you could have Q, T, and N, all three on the same line. They are collinear, okay. Looking at number 9, non-coplanar. So coplanar means that they're on the same line. Non obviously means that they're not. So if you wanted to identify 4 points, you could say like Q, P, R, and let's see here, a good fourth one could be X. Now, Q and P and X are all three on the same plane. But then R's, he's kind of on an island away from these two. So that means they're not coplanar since all 4 of them don't reside on the same plane exactly. Okay? When we talk about naming an intersection here, let me erase if it'll let me. Nope, it still won't do that. Okay, anyhow. We need an intersection of QT and UN. So QT, UN, what is the intersection? Well, the intersection is simply going to be point N. Right there's the intersection. Okay. And what's the intersection of plane? Now we're talking about a whole plane, LMN. So that is like the whole front face that's looking at us, along with QLS. QLS is over here on the side. The intersection of that would be this line right here, LQ. And you would state it as a segment or a line, LQ. All right. Moving on. Okay, guys, see here. These numbers didn't copy very well, but that's 11 and 6. Okay. They want to know what PR is. That's the whole segment. Okay. That's, here's P, Q, and there's Q to R. We want PR the whole way down. Obviously, all we need to do is add 11 plus 6 is 17. As opposed to the next one, where this is 26, BC is 18. They just want AB. They just want this little part right here. So we have to do the opposite, which would be subtract. So we're going to go 26 minus 18, and that equals 8 units. Moving on. Okay, so on this, you don't really have to plot the points. All you got to do is look for the points that aren't the same. Like 1 and 1, and your x's are the same. So for AB, all you got to do is you're going to take those points that are different, the 3, and you're going to subtract them. That's going to give me a negative 5. Okay. Now I'm going to do the same thing, but on the other point, if you notice, C to D, my x's are different. So then that simply means I'm going to take negative 2 minus 3, which also equals negative 5. If I get the same number here, then those two segments, C, D, and AB, would be congruent. All right? That's all you have to do. Look for the ones that are different in the x's and y's and subtract them. If the number's different, then they're not congruent at all. Okay, gang, 16 to 20 deals with this picture. All right? So they gave us the picture. You can see the right angle here. And you know, they told us this one's 45, which means this one's got to be 45 as well. All right, so it says, you know, you just got to use these. So like 17, name ABF. All right, so that is this guy right here. If the whole thing's a straight line, it totals 180. So just subtract these three from 180. That's going to give you F. So I'm going to take 180, subtract 45 and 45 makes 90. 90 and 50 makes 140. So I subtract those and I get 40 degrees. So this ABF is 40 degrees. Then they want CBF. So CBF is CBF, this angle from here over. All we got to do is add these three together. And we just did 45 plus 45 plus 50. We did it right here. It's 140 degrees. Use some common sense, okay? Just take your time, go slow. EBA, EBA. So again, that's this whole part here. So add 40 and 45. It's going to give you 85 degrees. And number 20 says name an acute angle, an obtuse angle, and a straight angle, and a right angle. Well, remember, acute's going to be anything small. So if you're going to name it, the acute would be, just for example, I'd say angle FBE. The obtuse angle would be CBF. And again, you could do different ones. These are just examples. The right angle would be angle FBD. FB, and the straight one, it's a straight line, ABC. All right. Moving on. This is the picture with the gymnast. Okay. I'm not going to redraw the picture of the girl doing gymnastics, but you got the letters, so it's close enough. It says in the figure of the gymnast below, the measure of ABD is 25 degrees. So write that in there. That's 25 degrees. Well, that's pretty crappy looking. Let's erase that. Let's try that again. 25 degrees. And DBC is 35. So that's this part here. That's 35 degrees. They want you to find the measures of ABC and CBE. Well, finding ABCs right here, that's not hard. All you got to do is add them together. So 35 plus 25, that's going to give you 60 degrees. And then to figure out CBE, well, you got to remember, if the whole thing is a straight line, folks, that's 180, right? So simply take your 180 and subtract the 60. And that means this is going to be 120 degrees right here. Okay? Just use some common sense. Remember, straight angle is 180 degrees. And that'll do it for chapter 1. So now we'll move on. Pages, here it is. Here we go. Okay. It says midpoints or bisectors. Anytime you have a midpoint or a bisector, okay, it is splitting the object in half. Okay, so let's see here. This is 6 point. Oops. Let's see here. Erase that. That was pretty crappy looking there. So anyhow, 6.5. That's PR. They want the whole thing. Okay, they want RQ, which is the other end here. So that's obviously going to be 6.5. And what's PQ? Well, just add them together. Mental math moment. 6 and 6 makes 12, right? Take 6 plus 6, that gives you 12. 0.5 and 0.5 makes 1. So that means your whole thing's going to be 13 units long. Okay? And the other one, we have this is listed as 2r, and this is r plus 15. Now, again, this line is bisecting the segment. So he's cutting it in half, which means this side is equal to this side. If we want to solve for the variable, simply say, okay, r plus 15 equals 2r. All right, I'm going to subtract that 1r over, and so r is going to equal 15. Okay, so that's how you find the value of r. Okay, 3 and 4 had a lot of people asking about how do I find this midpoint? Okay, well, here's all what you got to do. Just going to shrink that down a little bit. To find the midpoint, you just take the x's, divide by 2, take the y's. Whoops, it's not a y, it's a 2. Erase. It won't erase. There we go. Take the y's and divide by 2. That'll give you your coordinates. So I'm just going to do one of them here. Number 3, yeah, I'd take 0 plus 4 over 2, which is 4 over 2, which equals 2. So my x is 2. And the y, let's see here, I got 9 plus negative 3 divided by 2. It's going to give me 6 over 2, which is going to give me 3. So there's your coordinates for the midpoint of that segment. All right. Number 4 is the same way. I'm not going to insult your intelligence by going over it as well. Number 5 talks about a bisector. Again, that bisector, this segment is cutting the whole big angle in half. All right. So the one part that you don't see at the moment is that the whole thing is 141 degrees. So if we bisect it, it cuts it in what? You should be saying half. So ABD, the left part, if you take 141 divided by 2, should give you 70.5. DBC is also 70.5. And number 6, you've got, this is, whoops, 31 degrees. They want us to find x. And this is 4x minus 1. Again, this is a bisector. It tells you that in the directions, KM bisects. So that means this angle is equal to that angle, right? So to solve, you just set them up equal to each other. Whoops. Just minus. So 4x minus 1 equals 31. Add the 1. So I got 4x equals 32. Divide by 4. And x equals 8. All right, this next section, talking about supplementary, complementary, linear pairs. If it is talking about a supplement right here, that means it's going to have to add up to 180. So basically, I'm going to need to take 180 and subtract 29 to find what the supplementary angle is for E. Okay, so we subtract, that's a 1, that's a 5. So 151 degrees is what angle E has to be. In the next one, it says F complements G, meaning they both add up to 90. Okay, that's the difference there. Complementary adds up to 90. So I'm going to take 90. Subtract 76. Got to borrow from the 9, make him an 8, make him a 10. 10 minus 6 is 4. Got a 1. So F is equal to 14 degrees. Okay, 4 and 5 and number 9 are a linear pair, meaning the key part here is line. All right, so they're going to add up to 180 degrees, so you just got to take 61 and subtract it. So 180 minus 61 is going to give you 119 degrees. And in number 10, looks like I got some things missing here. Here we go. This is angle 1, that's 2, that's 3. This is 157 degrees. They want you to figure out the other angles. Well, folks, you got to remember, if angles are back to back like this, they're vertical, right? Which means they're equal. So this is 157 degrees. And then 1 and 2, don't they make a nice straight line? Or 3 and 4, which means they add up to 180. Now, mental math moment. Don't go for the calculator so fast. 157 is close to 160, right? 160 is 20 degrees away, and you just need 3 more. So 23 degrees is what we're looking for in angle 1 and angle 3. Okay, so continuing on here, we're going to look at the picture here on the right. This one over here. We first want to figure out AHB, so AHB. So we will figure out that angle there. So to figure out AHB, we also need to know that this BHC over here, whoops, that's the wrong thing there. That's the highlighter. Let's get the pen up here. Oh well, can't get the highlighter up here, but it's 31 degrees. Okay, so we want to know if, and here's the thing you need to know, guys. If this is a right angle here, then this whole thing over here is a right angle. So in order to figure out what just this part is here, all we got to do is take 90 minus 31, and we're going to get 59 degrees. Okay? And you just kind of use things like that throughout these type of problems. If you have a question about it, see me, and we can go over it a little bit further. Okay? But I'm gonna go ahead and move on here. If-then statements. I know in class we talked about 13. I'll just kind of talk about 12 with you, even though you didn't have to do it. It says a 60-degree angle is an acute angle. So if an angle would be 60 degrees, then it would be acute. So if this, then this. Okay? That's if-then statements. Nothing too challenging, I think, on your test to worry about that. Okay, 14. What property? You got the same thing. That would be the reflexive property. All right, we'll just kind of write reflexive property here. Whoops. There we go. 6 or 15. If 5 is equal to 6 and 6 is equal to 5, they just flip-flop back and forth. That's symmetry. And then the last one, if AB is equal to CD, CD is equal to FG, then AB is equal to FG. This is the part that connects them, all right? So this is called the transitive property. Not going to worry about 17. We talked about that in class. Number 18. You got the diagram here. We do have to just draw in those. It says complete the argument to show that SPQ equals 2 times RPQ. So here they're saying SPQ. They're basically wanting us to prove or show that it's this whole big thing is twice RPQ, this small part here. Well, right here, these angle marks kind of tell us that they're equal to each other. So the whole thing should be doubled what it really is. Okay? And I'm not going to go any further into that, just so that you understand that this whole entire chunk is 2 times what these little angles are right here. Okay? So that's chapter 2. Here in chapter 3, we're looking at this picture right here. Parallel, perpendicular, and skew. I'm not going to bother talking about parallel and perpendicular, just to make sure that you remember that parallel lines, the symbol would be this. Perpendicular lines is the upside down T. They make a 90-degree angle. Now skew lines, though, let's talk about this a little bit, especially here in number 1. Okay, it says PT, which is going to be this line right here, is skew with UV. Okay, or they want to know what kind of lines they are, and they are skew. So I just wanted to kind of explain, make sure you understand skew lines. They're on the same plane, or they're on different planes altogether, but they're never going to cross. These two lines are actually never going to cross each other. Okay, because this one's real tall up here, up high. This one's way back here in the back. Okay, of this shape. So even though they're not parallel, or they're on different planes, they're not going to touch. That's the whole point about skew lines. They got to be on different planes. All right. So if you have any other questions about perpendicular, parallel, or skew, just let me know. Number 6 here says, what can you conclude about FGH? FGH, this angle right here, and JGH. And it says, given that the two lines are perpendicular, so if they're perpendicular, that means they make a 90-degree angle. That means it's also 90 degrees over here. Okay? So what can we conclude about FGH is that FGH is a 90-degree angle. So angle FGH is 90 degrees. And JGH, all right? The only thing that we can really conclude about, I'm sorry, I kind of told you, kind of misquoted there. I said FGH, it should have been FJG. So this is, hold on, cancel that, sorry about that. It was angle FGJ right here, and then this one. So these two small angles, what can we conclude? The only thing we know is that they're all together going to equal 90 degrees, so that you could say that these two angles together, okay, and JGH, are complementary. Remember, complementary angles total 90 degrees. Supplementary total 180 to make a straight line. Okay? Number 7, we'll just talk about this one real quick. This is 2x plus 14. This is a 90-degree angle. It says solve for x, and given that C is perpendicular to D, so that really means this is 90 degrees. Just set your equation so that they're equal to each other. Subtract 14. So you get 2x equals 86. Divide by 2. X equals 43. Or I'm sorry, I did that wrong. Back up there. Back up. Can't subtract. Here we go. I was right the first time. It's 76. So 2x is going to equal 76. It is Friday. Now x will equal 38. That's better for your variable. But either way, the most important thing is for you to understand that this angle equals that angle simply because of what they gave us and telling us that those lines are perpendicular to each other and they make 90-degree angles. Okay, let's just spend a minute kind of reminding you what corresponding alternate interior, alternate exterior angles are. Number 8, it discusses that 1 and 2, so 1 and 2, notice that they're on different sides of the line. If they're on different sides, that's got to tell you right away that they're alternating. Okay? So number 8 is going to be alternate. And then where are they? Are they on the inside or the outside? They're on the inside of the line, so it's alternate interior angles. Now, number 10, it says 2 and 3, so 2 and 3. Now notice here, they're both on the same side of the line. Okay, but notice that 2 is located in this group of angles. He's in the lower left. And in this group of angles, 3 is also in the lower left. if they're in the same location, then that's called corresponding. Okay, corresponding angles. Number 12, we're talking about angle 4 and 2, so that's 4 and 2. They're both on the same side of the line, and they're both on the inside, so that just simply means same side, interior. Okay, same side, interior. Excuse me. Okay, 1 and 6. Again, those are going to be corresponding. I'm not going to really waste your time here. I will talk about number 11, 1 and 5. Okay, so 1 and 5. Again, let's make this one green. Whoops. 1 and 5. Notice they're on, again, different sides of that line. That's going to tip you off right away, telling you that it's alternate. And then, are they on the inside or the outside of the two lines? They're on the outside. So if they're on the outside, it means exterior. Okay? And number 13, 5 and 3 are corresponding. They're both in the lower left-hand corner of their groups. If you have questions about that, make sure you see me. Okay, number 14, they want you to find angle 1, angle 2, angle 3. And they give us this angle right here is 108. So you might be thinking, well, how do I figure that out? It's not hard. Just understand that, okay, first thing, look at angle 1 and him. They're both on the same side of the line, but they're not both on the interior. But notice that 108 is on the upper left, and so is 1. So 1 is also going to be 108 degrees, okay? And the reason why we know they are for sure is because these lines are parallel to each other. That's what those little extra lines mean I just drew in. Okay, now let's figure out what angle 2 is, this one right here. These two are touching each other, and they make a straight line, right? Straight lines make 180 degrees, so just subtract 180 minus 108, and that's going to give us 72. Okay, so angle 2 is 72 degrees. And now to figure out what 3 is, well, notice that 2 and 3 are both on the inside of the parallel lines, and they're on different sides of this transversal, which means they're alternate interior. Alternate interior angles are always equal. 72 degrees on number 3. That's how you can figure that out. Okay, number 15, all we're going to do here is set up an equation. This is, oops, pen please. This is 3y plus 1. This is 57. Notice that these are both, they're on different sides, so that's alternating. And they're both on the outsides, so that's going to be alternate exterior, but those angles are always going to be equal to each other. So all we got to do is say 3y plus 1 equals 57. Now we solve. They said they want us to find the value of y, so now 3y is going to be 56. And y is going to be 22. So all you got to do is set them equal to each other because alternate exterior angles are equal to one another. Number 16, these are same side interior angles because they're both on the same side of the transversal and they're both on the inside. So you don't set these two equal to each other. It's the only one that you don't because they're not equal. But they do add up to 180 degrees. So what you do is you say 2y plus 116 equals 180. So now we subtract to solve. Mental math moment. If that was 120, you'd get 60, right? But it's not. It's 4 more than that, so that's why it's going to be 64. Divide by 2, and y will equal 32. That's number 16. Those are same side interior angles. Again, these two add up to 180. That's why we set up our equation that way. Okay, last one here for chapter 3. We want to describe the translation using coordinate notation. So start with your x coordinate. Okay, now notice we're going to start right here. I'm just going to pick a point, so I'm going to pick right here. Let's change that color, green. Now, so for green, here we're going to move. We're going from this point over here to this point over here. So we move 1, 2, 3, 4, 5, 6 units to the right. So that's going to, and we're going positive on the x-axis, so that's x plus 6. Now for the y's, are we going up or down? You should say up, so that's going to be positive, which means now we're going to go up 2 units, so it's going to be y plus 2. That's how you do coordinate notation. If it were going to the left on the x, you'd say minus, and if it were going down, you would say minus for the y. That's the only difference. Okay, we'll move on to chapter 4. Okay guys, here's chapter 4. I'm going to start on number 5. Okay, 1 through 4 is pretty simple. Obtuse triangles, you got to have an obtuse angle. Acute, all the angles have to be acute. Equilateral, all the sides are equal. Isosceles means you have 2 sides that are equal. So I'm not really going to get into too much in depth there. But in number 5, if we want to find the value of x, I want you to understand something first, that all these angles, if you add them up, equal how many degrees? You should be saying 180. So what we're going to do is we're going to take all the angles. So we're going to take 2x minus 3 plus the other angle, which is 3x minus 15, plus the other angle, which is just a plain old x. So I'm going to call him 1x. And that equals 180 degrees. Combine your like terms now. We've got 2x here, 3x, and a 1x. So that tells me I want to combine those. 2x and 3x makes 5. One more makes 6x. Then I combine my whole numbers. It's going to give me a negative 18. And that equals 180. Add your 18 over. So 6x equals 198. And divide that by 6, and x will equal 33. Found the value of x. Always remember though, when we're dealing with triangles, the inside angles, the interior ones always add up to 180, which is a little contrary to number 6, okay, because if you're this angle here, he's 12x, he is equal to adding these two together. So if you want to set up an equation, you're going to say, okay, well 12x equals the 78 plus the 54. It's those two angles put together that will equal the 12x. So I'm going to combine those, so now it's 12x equals 78 plus 54. It's going to give me 132. Divide by 12. X equals 11. And number 7, this one's kind of fun. Notice that there's a single tick mark on all these sides, which means every side's equal to itself. It's called an equilateral triangle. So how to find x? Well, you could set up this side equal to this side, or this side equal to this side, or this side equal to this side. Me, I like to keep things simple. Those are easy numbers to work with. So my equation is just going to be 3x is equal to 15, because those two sides are equal to each other. So you divide by 3, x equals 5. It wouldn't matter which one you did, you should still get the same answer. Okay? Okay, number 8, Pythagorean theorem. It says find the length of the hypotenuse. Whoops, sorry about that. Hypotenuse. Remember, the hypotenuse is always opposite the right angle. He is letter C. A and B, doesn't matter which is which. Okay? That's 10 and 14. Okay? Okay, so all we're going to do is remember the formula. A squared plus B squared equals C squared. So we're going to take 10 squared plus 14 squared equals C squared. 10 squared is 100. 14 squared is 196 equals c squared. So you're going to add these two together. You're going to get 296 equals c squared. So now you want to take, in order to solve for c, you got to take the square root, because that means there are really two c's there. You got to get rid of them. So to do that, those will cancel. And the square root of 296, as soon as I find my square root button on my calculator on my phone, there it is, c is equal to 17.2. Just like that. A squared plus b squared equals c squared. Pythagorean theorem. We spent a lot of time on that. If you need any help, let me know. Okay, gang, got the distance formula here. I already wrote it on there for you. Alright, remember, here's your x1 and y1, x2, y2. They said find the distance, plot the points. You don't need to plot the points. Just plug them into this formula right here. Okay, we'll figure it out. So distance equals, all under the square root, my x1, which is 0, minus my x2, which is a negative 6. So notice I have two negatives there, so that's going to become positive. When we get that answer, we'll square it, equals my y1, which is 0, minus my y2, again, which is negative 8, squared. Now those two negatives, again, are going to become positives. So my distance now is going to be 6 squared plus 8 squared. 6 squared is 36, plus 8 squared is 64. Now what you want to do is you want to add those two together, and that's going to give you 100. And the square root of 100 is 10. So that's your answer for number 10. Okay, that's how you use the distance formula. Or that's for 9, I'm sorry. It's the same way for number 10 though. Okay? Just plug them into that formula. And you could actually have y2 or x2 minus x1 and y2 minus y1. It doesn't matter what order these guys are in, as long as they're both the same. If you go x1 here, you go y1 there first. Okay? So just make sure you're careful. Alright, I'm skipping over to 16 here. If you have questions on the other ones, let me know. But there's angle 1, or 3, there's angle 1, this is angle 2. This is 31 degrees, that's a tick mark. There's a 90-degree angle, that's 44 degrees. You need to figure out what the rest of the angles are. This isn't too bad, really, because if you think about it, here's a 90. Okay, so add 90 and 44 together. It's going to give us 134 degrees. And then take that away from 180. Why? Because there's 180 degrees in every triangle. So 3 is 46 degrees. Alright. Now we need to figure out 1 and 2. Well, here's the thing about 1 and 2. Notice these tick marks here. Okay, I forgot to mark this one. The tick marks are going to show us that if this side and this side are equal, their opposite angles are also equal. So the opposite, that means this one's got to be 31 as well. Now 31 and 31 makes a total of 62 degrees total. So what's that leave us with for number 1? We got to subtract. Mental math moment. If you had 60 there, that'd be real easy, it'd be 120. But we don't have that much. We have one less, so it's 118 degrees. That is what angle 1 is, 118. Okay? Just remember, every triangle is 180 degrees. Okay, the last ones here, all you gotta do is take the shortest sides and add them together. And they gotta be bigger than the third. So add 5 and 8, you get 13. Is that bigger than 18? Nope. So that's not a triangle. Okay? Here you get 7 and 7, you get 14. Is that bigger? Nope, not a triangle. Okay, the shortest side's got to be bigger than a third. Here, you add 20 and 24, you get 44. Is that bigger than that? So then we'd say yes, that is a triangle. That's all you got to do. Add the two shortest sides, and they've got to be bigger than the third. Okay? And that's a wrap for Chapter 4. Here is Chapter 5. You were told to do 1 through 8. I'm not doing 8 because this proof is not really like one we've done with the extra step. Not going to really worry about that. The proof you have on your test is not that challenging. It's like one that you saw not so long ago on a quiz. So if you got your old quizzes and tests, take a look at that stuff, because that's where the answer or the questions are coming from in your exam. Number 1 says the two triangles are congruent. List all pairs of congruent corresponding parts. Corresponding parts are just parts that would be in the same location. For example, ST and YZ. Those would be corresponding parts. Okay. Same way with angles. R would be congruent with X, be Y and S, and of course T and Z. Okay, so that's just how the corresponding parts work. Number 2 and number 3, they say the two triangles are congruent, find the indicated measurement. Okay, this is 11.8 right here. Switch this for a second here. This is 78 degrees. That's a 10. This is 46. So first they tell us in number 2, find angle L. Okay, so find the measurement of L. Now these two are congruent. They tell us that up here in the directions. So who is L like? You should be asking or saying to yourself, he's like angle U. So L is 46 degrees. Okay? And then TU, how long is it? Well, again, he's corresponding parts here with this KL. So TU is going to be 10 units. Number 4 and 5, we're just talking about which postulate or theorem would you use. Again, remember, we've got choices. You got side, 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 side angle, side, angle, side, angle, 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 side, and hypotenuse leg. So taking a look at this triangle, I would say, okay, I got a side and a side, side and a side. And of course, don't forget, we've got that guy there, so it means we have a third side, which means number 4, we would use side, side, side. In number 5, the biggest thing that you should see right away is this. The right angle should tip you off to start thinking about hypotenuse leg. It's the only postulate we use that deals with a right angle. So, you've got a right, we did a checklist. I used to say, okay, 1, you got to have 90-degree angle. Check. 2, you got to have a hypotenuse that are equal. Check, check. And then do you have a base that's equal? Well, you do, because that guy's equal to himself. So that's why we would use hypotenuse leg. 6 and 7, last two we're going to talk about. It just says, does the diagram show there's enough information? If so, tell us the postulate. You're going to use the same postulates that we talked about before. So, taking a look here, okay, we got a side and a side. I got an angle and an angle. Now that's all they give us, but when two lines intersect, they make vertical angles. So you got that other angle right there that we could consider, which means you got AAS, AAS. So you can say, yep, there's enough information, we can use angle, angle, side on number 6. And lastly, number 7, we got a couple parallel lines here. They're parallel because of that little arrow right there. So let's take a look at what we got. We got a side and a side. And we've got these two angles here. So we've got these two angles. That's going to be an A and an A. All right. Now you're sitting here thinking, is there anything else? Well, here's the kicker. Being that we've got parallel lines here, okay, we also have alternate interior angles here, which means then I've got an angle here and an angle here. So you could go angle, angle, side. Or you could say, well, we could go, these alternate interior angles are equal, which again means you got an angle here and an angle here. So you could use angle, side angle, or, whoops, we don't have any of that in geometry. Sorry, we have angle, side, angle, or angle, angle, side. Okay, that's it for your review. Hopefully it helps you out. Have a good exam time.